Welcome to a new test and teardown video. I don't know how much testing I'm going to do in this video, but I'm definitely going to tear down some stuff here and let's see what happens. So this is definitely one of those really nasty lasers. So the company here is called Cyonics, and this laser here is a model 220115 SLB. It is from 87, so it's quite old, and I think this one was decommissioned because it was too old and didn't work anymore. So I don't know if we are able to get even a tiny little beam out of it, and if the power supply works or not. Got a little bit of electronics in here, so definitely we need to open everything first and inspect and figure out what we got. So this cooling lid here is, well, there's supposed to be a lid, right? So the fan can pull air correctly through the tube cooling fins. Look at those big beefy cooling fins on the tube. There's also some isolation and stuff, and that electrode down there is probably, I don't know if this is the anode or the cathode or anything yet, but I'm looking so much forward to figure this out. I've been looking in here the whole, and this seems like there's a mirror. There's rotated a little bit to the side, so I expect there's some optics and probably a little crystal down there. That is for changing the wavelength to another color. So I don't know if this one is blue or green, but it can be probably one of that, because I think this one is one of those Argon Ion lasers. So that means it's actually running at a low voltage but a very high current. And so here is the power supply. Cyonics Uniphase power supply. We even got the key for it, variable power control, and a confusing multi-connector here. That is the connector for the laser unit, and that cable fits perfectly in here. That is the mains. Let me show you the, yes, here we go. So the other end of the power supply, and look at that, 115 volts but 20 amps. So that is one beefy power supply. So that is 2 kilowatts, right? How nice. So this is the mains entry. What a nasty connector here. I hope that this is reconfigured for Europe voltage. So I definitely need to open the power supply as well. But what is the most interesting to open? I don't know. I also got this connector here, and this one fits this funny multi-connector here for the power supply. But the other end, look at that. We got 2 little wires, and those are very thin. We got a lot of medium wires here, and those are all white. And then we got those 2 wires. So this is probably remote on-off control, right? I mean, that is quite logic, but all those, we don't know what that is doing. I've been trying to Google a little bit around here, and I can't find anything really, so yeah. Are we able to do anything with this? Well, at least let's start to open the power supply and have a little look what is going on in here. Let's look a little bit at the power supply first. It looks like quite a complex power supply, to be honest. I did not expect it to be this complicated. We got a classic UC switch mode controller, some op amps and comparators and yeah, all that classic stuff. A lot of optocouplers and all the low volt side stuff. So this is primary side. And there's probably some auxiliary supply regulator here that needed a little bit extra isolation to the chassis. The chassis here is only a few millimeters away, so that is probably not so good. And that is the output connector to the laser. Look at that, all those control signals. Well, that is a little bit interesting. We got some very thick wires and some medium thickness wires and tons of control signals. So that is going to be interesting. Other than that, the power supply consists of a little auxiliary transformer down here. We got a big beast of a transformer up here, and we got 2 halves of transistors and a single diode. And that is, of course, the step down inductor and filter capacitors for the high voltage output. There's a current sense here, so of course they're running in current mode. So as far as I can understand, we got the input, the mains input is going in here. It goes to the mains switch and it goes through a filter, input filter here, and then it goes to the transformer, and that will probably be the different input voltage selections here. So this is how you configure it, and I cannot find the goddamn manual for this, so that is a little bit annoying. So I don't know if it is wired for 110 as it says on the plate here. I mean, this one was found in Europe, and I am in Europe, so this should be 230 volts. So that's always a problem. Why don't people update the voltage labels on stuff when it is reconfigured for another voltage? I mean, I must always be able to trust a voltage range sticker. So that I'm always super angry and frustrated when people do not update those stickers. I mean, a permanent marker could be perfectly fine. I don't really care about the method. It must be updated to fit whatever you have done. So that is my normal rant about that, because that is a problem. Yeah, so that's quite what it is doing, this power supply. I think this one will generate about 110 volts at about 8 amps. The output current is variable by this power output knob here. And yeah, so that is actually the business end of all this. That is to generate this yeah, quite high voltage and quite high current to drive this the tube. So yeah, I didn't find the rectifier, so there must be a rectifier somewhere down here. It's impossible to see what's down there really, but you got all those capacitors, or those are probably just in parallel, and running this a half bridge push-pull circuit to this inductor, right? So, and this is simply just how you create the output voltage. Quite nice. Let's look a little bit inside the laser unit. So I took off the lid here, and yes, of course I know this one contained the beryllium, so so don't need to tell me about what that is. I know what it is, and I know it's gonna be fine, okay? There's of course a nice label here about it. So that is of course the tube, what you're looking at here. In the end here, that will be the filament wires. So on this type of tube, the filament is most likely about 3 volts and quite a lot of amps. So this is why we have those big heavy wires, and this is probably running on AC, and that is probably also what this big bad boy of a transformer is doing, that is down there, that is driving the filament. So that is definitely what I think is going to happen here. So what I want to do is I want to measure the AC voltage on the filament, and then I want to crank up the input slowly and turn it on and all that kind of stuff, and hopefully I will be able to see the 3 volt AC here. So that will tell me that the voltage ratio and the configurations for input voltage on my power supply is done correctly, because otherwise I have no chance to know how that is working. So the big hole here in the middle, that is not a service lid or an open and have a look hole. No, that hole we have here in the case that fits around here, that is where the fan was mounted. So there's supposed to be a big powerful fan here, and the wires were supposed to go down that hole. And the reason why I know that is that this connector here is missing the 2 blue wires for the fan. And so if you unplug this for the fan, the control unit will see that the broken 2 orange wires is not connected, and then it will stop everything. So the orange wire goes via the temperature sensor here. So it will think there's an over temperature and it will shut down immediately if you unplug the fan connector, right? So the 2 blue wires here, they go to the fan controller board. So here is a little controller board that is doing the fan. It's running on 115 volts AC mains input, and the reason why I know that is there is one of those. Let me swap this around. Hang on, like that, so you can see it. So this is one of those hour counter things, and they're really cute. Why is it doing this annoying? So this one is running on AC, so there's a little diode in here, of course, because they actually run on DC internally, and the DC voltage moves some particles in this mercury, and this way the mercury actually moves real slow, creating like a time indication display. But what I can see here is there is no such indication. Normally you will have a tiny little hole, like a millimeter wide, starting from 0, and then this hole kind of just moves all the way to the right. And that is not the case here. I don't see it either at the start. Oh yeah, is it like that? If we look real careful, is it down there? Is it really? I will go and have a look much more careful, but I actually believe this is where it is. So that means this thing has like never been running, and is that really possible? What is the odds? Yeah, so that is that could be a problem with that voltage, but that could also be a low power tapping on the transformer that is just running the fan and stuff like that. So yeah, maybe that is also why the fan was maybe not working, and so I don't know what's going on here. And there's another problem that I can see here, a mechanical problem. Those 2 screws here that holds the tube, they're actually halfway out, as you can see. So that means I can actually lift. See, I can lift the tube freely, and that is not good because it's mounted here in the anode. Oh yeah, by the way, the 2 filament wires, I actually believe that those are actually also the cathode, because there is no other wire here on the tube, and all that metal here on the tube is not electrically connected to the filaments. And I also measure something very close to 0 on the filaments. I am going to measure exactly how many milliohms in a minute, and then everything here is just connected to chassis. All that is fine. Anode here is looking like it is connected, but it is not. So anode is isolated from the chassis here, and there's probably some millimeters distance to all this, the cooling here. So this is where all the light comes out. There's a little optical or a little mirror or something like that I can see in here, but it's looking like it is bent. It is not straight. So that worries me a lot. So there's definitely something here that's not supposed to be like that. The 2 thin wires you see here, they go down to that mirror. So there's a little light detector mounted. Maybe I can show you that. So this PCB here is called light. So there's a light detector that senses if this tube did fire or not. So it will probably have 2 or 3 retries. There's a high voltage spark pulse. This is the start generator. This is the anode voltage. That will be the 2 red ones here. They are in parallel in the cable. So they go, as you can see here, to an inductor. And the series of that inductor goes to the anode, right? But there's also another little active device down here, a power transistor, a little driver transistor, and yes, a little IC, probably a little optocoupler and stuff like that, and a capacitor and a resistor and stuff like that. So the trick is it charges the capacitor, and the capacitor is getting fired via the transistor to the inductor, and that creates, as you can see, there are several windings on this inductor here. We see some other windings. You can probably see them down there. And so that generates a high start pulse added on top of the anode supply, and that will make the beam to start, right? And then you will have a low voltage, high current. So yeah, so first I want to play a little bit with the filament. So now I'm measuring with a 4-point ohm meter, and we got 30 milliohms. And I actually believe this is normal, because you can imagine this is a cold filament, and the filament wire is actually made just like a bulb. So the warmer it gets, the higher resistance you get. So this is running at 600 or 700 Celsius down here. So that means the resistance is going to be about 0.2 ohm when it is warm, and at 3 volt it will be about 15 to 20 amps, and that will be the normal operating filament. And as you see here, there's a little yellow wire, so I believe it's actually measuring the voltage drop in that wire, or it is measuring that it is connected or something like that. So I did manage to go a little bit ahead here. Yeah, I removed the fan controller, and then I could mount the tube a little bit better. And again, of course, everything here is the inchy kind of screws, so it's not so easy to find tools that actually fit. But so far that is done. I was also able to find a little bit of manual and information online. So what I have found so far for the power supply, I found pinouts for the remote control connector. And that remote control connector, we have inhibits and we have enable of the internal power adjustment potentiometer. So what you need to do here is you need to short circuit or connect pin 12 and pin 13. So that should enable this power adjuster, and that was not done because we had no pins in those 2 holes. So I had to remove some other pins that we're not using and move them to 12 and 13. And the blue and the yellow wire, remember the big thick ones? That was a remote inhibit. So that is 36 and 37. So I've connected those as well. So that means now I should be able to plug this in, and it will be enabled and everything is fine. And then this will be my power adjustment when I turn on my laser here, right? I also found the pinout of the connector that goes to the laser unit, and here we can also see exactly how it is done. With this is a filament, and those are the anode supply and all that kind of stuff. And all the other pins here, what they are doing, they're doing supply for the fan. So that's this, and this is indeed a 115 volt supply for the fan. So that worries me a little bit. We also got some signals that is, of course, for the inhibit and also for the light controller. And that is also how this system works here. It measures the output. And we also found a schematic for the starter system. Oops, sorry about that. So that starter system down here with the inductor, the SCR, the capacitor, there's an op amp and all that kind of stuff. I should put in the schematic here. I found it on a really good laser page that explains everything, and so I should put in a link in the description, and I'll put in the schematic here so you can see how this laser starter circuit is doing. And it's a full self-maintained starter pulse system, and the inhibit is via the optocoupler, and that is driven by the feedback signal from the light detector. So I hope all that is working. I feel I'm ready to try and power up this system for the first time. I added the two shorts and made this connector nice and stable. Everything is inspected. I don't have anything loose and or any dark or bad spots. My laser unit here is also nice and fine. What I want to do first, before I hit the start, that is the key we got here, I just want to see if I can power it up. And I want to take my Vario and dial it up real slow. I even marked my mains connectors here, so I'm not going to screw that up. And then I will dim the light so we can see if anything is going to happen. So first we plug in, and yes, we have ground and everything. And I think I should turn on my mains entry, and my key is in off. And then I will turn on my mains, and then I will slowly dial it up and see if there's any crazy watts. So I am now at 90, 100, 115, and it's using 100 watts. So I think it is powered up. The entire power supply here is powered up, but it's not enabled the secondary or the laser. So now I'll turn it off and get a fan for the laser. Let's try again. I close the lid for the laser unit. I put on an external fan. So that is just running. It's not as powerful as it was supposed to be, but I only expect to run this for a second or something. I just want to see if there's a little dot. So what I've done, I've taken a little piece of paper that I have angled like that. So if there's any kind of light coming out of the laser, we should be able to see it right here, even if it's just for a short circuit second. My variable mains is limited for 2.5 amp, and I know that this one will use a little bit more than that, even at the lowest power. So I expect it will blow my fuses, and that is intentional for this very first test. I leave this on here, crank it on. So now the power supply is on, 100 watts. I wonder why it's using 100 watts. Is there filament on? Because 100 watt is quite a lot in idle. So what happens if I dial this? Are we going to see any kaboom? We'll see. $103, 100 and... I don't see anything going on. Yes, there's light! Light! We got laser! Did you see it? Did you see the light? Ha ha ha! It's working! Woo! Let's try and put this a little bit into perspective with this super nice gas discharge and ion funky stuff laser here, and this power supply that requires 20 amps at 115 volts input. So that is a lot of kilowatts to give you 27 milliwatts of laser out here. Of course, it's very visible when you look at it with your eyes and for experiments and all that kind of stuff. But if we put this a little bit into perspective, a tiny little laser like this tiny little one here gives a 1.5 watt, and if I hold this still, it's gonna burn a hole into stuff. I don't want to do it onto my hand, but this one you can easily put to your hand and you can't even feel it at all. So yes, a lot of things happened, and of course today we're using LED lasers. So I don't want to show you a lot more about this video, because the next move is to get a very powerful fan and to get a very powerful step down transformer, so I can run this at its full potential. But I want to end this video now. So thank you very much for watching. Bye bye.